Hello, everyone.
Hello.
Welcome to our session, Building the Dynamics 365 for Financial Service. My name is Kamil Koclega, and I'm software engineer at Microsoft Development Center Copenhagen. And I was one of the team members who created the service and brought it online, of course, with a great help of all other teams in Dynamics NAV organization. And welcome also my colleague.
Hello, I'm Constantin Daniil, Kamil's colleague, and we're excited to show you what I've been working on.
And again, thank you very much for coming. We know this is the last session, so it's really nice to see so many of you. And as we said, a lot of people worked on what we're gonna present today, so I think it's a really great privilege for us to be here today and to show you our work. So we really hope you will enjoy it. So let me tell you a little bit about what are today's session objectives. So of course, we'll start with telling you why we built the Dynamics 365 for financial service. I think Vincent and Thomas told you a little bit about this during the keynote. We'll try to tell you a little bit more, so you get a better understanding on why. And after that, we'll switch more to how. So we'll give you some insight into how the service is built, something definitely more you've seen before. Some things might be not a surprise for you in terms of how it's built. Some hopefully will be an interesting thing to listen about. And afterwards, because first we'll talk about the entire service, then we'll concentrate on the NAV, because it's really at the heart of our service. So we'll explain what kind of changes we made in the platform, so it benefits not only the service itself, but also all the installations on-prem, and those of you who run it on cloud definitely will also benefit from all those changes. Afterwards, as you will already get a really good understanding on how the system operates, we'll concentrate more at the runtime of the service, and particularly we'll tell you how we monitor it, because monitoring was one of the most important aspects of the project. We put a lot of effort into ensuring that we know 24/7 what exactly is happening within the system. And of course, Q&A at the end, so feel free to ask us any questions. We'll be also available to answer questions after the presentation, and I think also tomorrow. So
Absolutely.
we truly hope you will enjoy it.
So, why was Dynamics 365 for Financials built? There are many reasons, but the most important one was that we wanted to empower every partner and small and medium business on the planet to achieve more. You may ask yourselves, well, what does this mean specifically? To find out the answer, we must look towards the future, but we must also gaze back on the past, specifically NAV's past. Anyone remember these days, the DVD era? Thank you very much. So let's remind ourselves of how the process used to go. Well, we at Microsoft would work on the newest version of NAV, and when it was done, we would ship it to all of you, the partners, so you could work your magic. And you did. You created amazing verticals which satisfied particular needs for small and medium businesses around the world. But once your work was done, how would you get your IP to the customers? Quite often you'd have to engage with them and go over there so you can help them with the deployment and setup process. And if we were to remember this era, there were, let's say, a 3-year delay between Microsoft releases, and then we switched to a 1-year cadence. But even so, it took a lot of time between the moment when NAV would actually be out, and then it would be in the hands of the customer. Months, perhaps 1 year. And in today's day and age, this is not enough. In order for customers to stay competitive, they need the latest tools and technology. So this process needed improvement. And we took a step back and thought to the very building blocks of the process. We had NAV, and we had the partners. And what was the major pain point? The deployment process. It was long and it was difficult. So we thought, how can we improve this? And we turned towards the cloud. So we created a tool set, I presume some of you remember it, and using this, you deployed virtual machines in Azure. These virtual machines had NAV and SQL Server installed on them, and customers could just log in and use the product. And so we moved from the DVD era to the infrastructure as a service era. But still, this was not enough. We needed more. We needed to evolve yet again and become even more efficient. And so we gave you the Dynamics Managed Service for Partners. and entered the platform as a service era. Who knows this? Who has used it? Thank you. Okay, quite a few of you. So let me just give you a brief explanation of what it is. Using this, a partner can upload their application, and then they will deploy application tenants. And in these tenants, customers from around the world can log in and try the latest version of their application. And it offers a bunch of useful features while having this familiar NAV interface which you're used to. And although it is very efficient, whenever you launch a new version of your application, you need to create a new application service and move your customers to it. And even with this, let's think about our customers. How do they actually get their hands on NAV today? Well, they engage one of your partners and explain their specific business needs. And after that, you have to sit down, design the solution, code it, give it to them, or upload it here and create an application tenant. And only then can the customer actually use NAV. How much does this process take? A few days, you might say, a few weeks. But we live in the world of the now, now, now. We cannot have customers waiting so long. They just want to be able to use NAV in mere seconds. And they cannot do that. Well, actually they can. Welcome to the new world. Welcome to the future. Dynamics 365 for Financials is NAV as a software as a service. It is the new branch of our product, and it is Microsoft's solution to bring NAV into the hands of every small and medium business around the planet in mere seconds. You may say, well, that sounds impressive, but how does the process actually work? Well, allow me to guide you through the customer's eyes. Some of you have already seen a preview of this when Vincent did it this morning. As a customer, I go to our website where I can find out information about NAV and why is it suitable for my business. And then, once I'm satisfied, I click on Try It, this button right here. I'm taken to this page where I enter my corporate Office 365 account, and after confirming my identity, I enter my user information and company information. I then click on Start, and I'm here. This is what we call the landing page. And this thing loads, and in just a few seconds, boom, our customer is already in NAV, and is the financials application. They get this nice welcome experience, which is like a tutorial of our most useful features, and they can already, start modifying items, posting sales invoices, and running their business. So just to give you a very brief overview of our process, there's the customer, there's the walkthrough I just showed you. Again, they use their Office 365 account, which, as you know, is stored in our Azure Active Directory, which is the place where we have all of our corporate and personal accounts, such as Hotmail. And even our landing page, the one I showed you, queries AAD, and a sneak preview, of course, some magic happens in the background with the sync daemon and our service. And in just a few seconds, as I said, the customer is in the financials applications. But as you can imagine, this is a general application, right? It's the same for every customer. So some of them have specific business needs. What happens when a customer encounters this? Who do they go? Where do they turn to? Well, the answer is AppSource. And this is where you, the partners, come in. This will contain your code. You shall write extensions and put them on AppSource, and customers will be able to enable them. And thus, they'll solve their particular business needs. Think of Dynamics 365 for Financials as Microsoft's way of bringing the customer to you. So we have seen how we can get from a website into NAV in just a few seconds. And then we have AppSource. As our phones have the Windows Store, NAV will have AppSource. But there has to be some magic happening in the background, right? How do things happen? Care to tell us?
Thank you very much. So I think my colleague really nicely presented you our journey, where we started with the DVD era, and then we improved our tools, and we took more and more tasks to be, really not a problem for you. You should more and more concentrate just on building your solutions and less on the entire infrastructure. So in Saas, when we look at the Saas, I think we'll start explanation with presenting you the entire Dynamics 365 family. So those are the services that currently are available in the suite. And you can think of this more like Office 365, but in terms of the CRM and the ERP software. So you can expect exactly the same seamless experience in all of those pieces of the system. So the UI should be similar to all of you in all the software within the package. It shouldn't be a problem to switch between those. They should cooperate nicely all together, and of course with other Office 365 services. So the NAV with a great functionality, with all the integration we worked on during a couple of years with Office 365 team and Azure team, it really enabled us to become a part of this family. But today we'll particularly talk about the financials module. So again, we'll start with a really high-level explanation of the system. We'll first list all the components that are present in the system, and then we'll dig a little bit more. We'll go to the lower layers of the stack so you get better and better understanding of how the system works. So the financials, Dynamics 365 for financial service. Of course, it is built on a product we all know and love, so the NAV is at the heart of the system. But there's 5 seconds to sign up. So we remember when we started the project, and Marco, our GM, came to us. He said it should be 5 seconds sign-up time. So we worked really hard in order to provide that experience for you. And again, we really encourage you to try it out yourself after the presentation. And that was one of the goals. Extremely fast sign-up time. Whatever must happen to enable the tenant in cloud, it should happen extremely quickly and in the background and completely transparent to you. So you can enjoy the product and all the other Dynamics 365 services. And as we host the product, it's also always current. So whatever we must improve in the product or would like to improve, like introduce a new functionality, it almost immediately reaches you as an end customer. So when you start using the product, you will notice all the improvements along the way. There will be no delay as we work on it. And there's shortest time to value, both for us and for you. So for us, if we want to extend the product, if we want to improve some functionality or introduce a completely new one, it's a really short turnaround before the customer is using it. And thanks to our great monitoring and telemetry information, we can continuously make that time even shorter. And the app source, so as Constantin already mentioned, we built the financials, Dynamics 365 for financial service. But we also are looking forward to work with you guys so you can do your magic and build great extensions so you can fill all the requirements possible customers might have in terms of particular functionality. And then, again, a rapid feedback. Because this is an online service, we also have appropriate feedback channels. We extremely quickly get it, and we can extremely quickly react to it. Again, thanks to our telemetry, pretty often we solve the problem before it is reported. We know about all the problems, if there are any problems, before the end customer is affected. So this is a really great functionality when you run a cloud service like this. And of course, because at the heart of the service there is Dynamics NAV 2017 and 2017 plus, because remember, we'll be upgrading the platform and the app. Therefore, it is powered by all the great features that has been introduced into the product, like, of course, Azure infrastructure, because it runs on it, but also the Azure machine learning, Cortana intelligence, or Power BI, plus all the new features that will be coming to the product. So we took a look at the family of Dynamics 365 services. Then we briefly told you something you already knew, probably, that it's all about NAV within the financials module. Now let's take a look at the service itself. So we'll start with presenting you a list of components, and then we'll explain in details what each component is responsible for. So you've seen already management portal. It was used in Paas. And what I want to emphasize here, while we work on the product like this, Dynamics 365 for financial service, we didn't try to build a new components. Instead, what we wanted to do is to look at what we have available that our customers are using and our partners are using, and we try to use that functionality and improve it. So not only our newest Saas service gets all the great new features, also the previously released Paas service also benefits from. And that's why we have the management portal, but hugely improved, and therefore it's also used in Paas. So more and more people benefit from our work, and that was basically the kind of like one of the goals. The same for the platform changes. when we made the performance test and we saw some places for improvements to make the service even better and faster, we made all the improvements in NAV Platform. So whether you run on cloud or on-prem, you all benefit from our work. So it's not just SaaS specific, because as it was mentioned during keynote, also on-prem business is extremely important to us. So that was basically one of the goals while we work on the project. So there's a management portal. Then there's, of course, a component which I believe Constantin presented on a previous slide that communicates with the AAD. That's our connection point. Then there's provisioning service, and that one I'll explain on the next slides. And of course, there are clusters. There are clusters that hold the VMs with the NAV deployed. And of course, there are databases. And here there were also slight changes when compared to Paas. We'll also get into details. So of course, Azure SQL servers with both app and tenant databases. And we can't forget about other services we are using. So those are just few of all the Azure services we are using in the Dynamics 365 for financial service. And you can see, of course, there's one that we call new features. And because we are one big Microsoft family, we get in touch with all internal teams so we can benefit from all the new features that are being introduced to Azure. So not only us and you and your customers can benefit as well. And that's why, for instance, Cortana Intelligence or Azure Machine Learning is introduced into our product. This is thanks to great cooperation between the product groups within the Microsoft. So the management portal. You've seen it in Paas. You can see it right now in Saas. What is it? Well, it is based on the Paas management managed service for partners portal. However, we took a closer look at it, and we thought how we can improve it even further, so it can work greatly with even bigger load. Because in Saas we can expect much bigger number of tenants, as anyone in the world can possibly try it out. So we looked at it and we redesigned it so it's pure UI. You can think of our portal as a kind of Azure portal, but for NAV resources. So we try to keep the stack extremely thin on the portal, so it's purely our database for the resources, for the information about the resources, and the UI, so we get a nice overview of what is deployed. And we changed it so whatever else, like business logic or the provisioning engine, we moved all of this outside the portal. So we kind of followed that approach that I believe Vincent mentioned during the keynote to make it more microservices based, so it can scale better when under the high load. So it is the same portal, but redesigned for higher throughput. And again, because this is the component we used in Paas, also Paas benefits thanks to those changes. Then there is a sync daemon. So a sync daemon is the component within the system that talks to AAD. So whenever any of you signs up, it gets the information about the new customer coming up, and it reacts appropriately. It ensures that there is a new tenant ready for you, and when it verifies that everything is fully functional, it returns the information to AAD. Then the landing page gets the information from the AAD about the completed provisioning operation. So all of those components cooperate, so in the end, you are redirected to a fully running solution within a few seconds. But how does it happen that it's all done within 5 seconds? So one part of the magic here is that we create the buffer tenants. So we have a pool of tenants that we create upfront before you sign up. So we have a particular number of Azure SQL clusters, we scale as needed, and we add more and more tenants so they're always ready for you. However, of course, this is not the only thing that has changed. As you can imagine, we need to create appropriate database, we need to set up the tenant. There are a lot of steps that we also improved as we created the system. A really simple example, for instance, the NST that is capable for detecting the new tenants within 30 seconds. 30 seconds wasn't enough. So we improved it so it's almost immediate. And like when we look at the entire process, in the beginning the process took longer, obviously it wasn't 5 seconds. And then we were trying to shorten the time more and more. So really, like at the end of the project, really every second counted. If we could save 2 seconds, we did save 2 seconds. It became really important for us that the process is really short. So the buffer tenants, when you sign up, the tenant is taken from the pool, and only really minimum required reconfiguration is done to the system. So it is mounted, there's a new domain name assigned to it, there's of course some company information set up and additional information provided to the system. So those post-deployment operations are really limited to minimum, so it's done the fastest possible way. And the buffer tenants are provisioned automatically as the pool size decrease. And of course, it's dynamically either speeded up or slowed down depending on the rate of the signups. And again, we improved also the way we provision new tenants, so we can provision in parallel a lot of them. And just to tell you, it's been a lot of test runs. We did a lot in order to improve it as much as we can, eliminate any concurrency issues while creating more tenants in parallel. And thanks to all this work, that was our goal. We really wanted to make sure that the time is not spent on our infrastructure tasks while you sign up. We wanted the time to be spent on the systems to cooperate with each other, synchronize, and react to the changes happening. So really those 5 seconds are mostly spent, of course, on some finalized setup of NAV, but meanwhile, other operations happen. So we can state that actually the most of the time is spent on propagating changes into the AAD service. And there's a provisioning service. I mentioned that we improved the management portal. One of the steps to make it perfect, even more perfect, was to move the entire logic that can be scaled better as a separate service. So we created so-called provisioning service that became our PowerShell execution engine. And because we use Azure Service Fabric, it is highly scalable under a high load. So for those of you who haven't heard of Azure Service Fabric, you can think of this as a distributed system that makes it extremely easy for you to create, package, and to deploy the applications. So basically, it eliminates any troubles you usually would have while setting Azure VMs. You worry only about the app. Of course, you need to conform to some special design patterns while building the service, but if it's done right, the service scales extremely well. And that's why we really that's why we decided to use the Azure Service Fabric for hosting this specific component, because it's under high load, especially during the preparation of the tenants and during entire process of sign up. So I explained to you, I think, 3 components, but there is also the heart of the service, which is the clusters containing both the VMs and the databases of NAV. So Constantin, if you could tell us more a little bit.
Of course. So as Kamil said, the clusters are the very heart of our service. You can imagine that we have to run NAV simultaneously for thousands of potential users. So we of course need multiple virtual machines on which to host the product and multiple databases to store the information. And we group them into clusters because they offer 2 huge advantages. First of all, it makes everything scalable, and secondly, fault tolerance. If one of these resources goes down, the others are there, ready to take its place, and thus ensure service uptime. But there's one very important thing about scalability. It has to happen fast. At some point, we can have thousands of simultaneous users accessing NAV at the same time, while other points we can have just, let's say, a few hundreds. So how can we ensure that we can scale the virtual machine numbers up and down adequately fast? Creating a new virtual machine just isn't enough because NAV has to be installed on it. And I'm sure at least some of you, right, have installed NAV on a machine at some point. So it takes a bit of time. How did we make this installation go faster? The answer, we don't install NAV. Instead, what we do is we use Xcopy, and we push the necessary files and DLLs to those virtual machines. But as you may know, NAV has prerequisites. There's IIS, there's the .NET framework, and many others. If we were to simply Xcopy all of those prerequisites and NAV, that would not really be on optimization because it would still take a lot of time. But the good news is that the very images those virtual machines are made from already contain those prerequisites. So when a virtual machine is spun up, it already has the components, and we just need to copy the files and DLLs NAV needs. And then, based on the configurations in the management portal, we make some last-minute configurations using PowerShell scripts, and thus we have running NAV on virtual machines which can scale up when need demands it, and down, and thus avoid needless resource usage. But the virtual machines aren't the only thing we have improved. A very important thing are the databases. And let me take you to a small historical trip of how we did it. We initially analyzed the different performance tiers which Azure offers. And we looked at Basic, which is the cheapest one, but we didn't go for that. We went for S0, the standard one. And we created multiple S0 databases to host our customer data. But what is the problem? We know this in general happens for all systems with concurrent users. You do not control which database gets hit. Who knows what users are logged in when? At some point, a lot of these databases will be idle. Sorry about that. A lot of these databases will be idle, while others will be simply hammered because the users whose data is on them are logged in at the same time, and they will have a suboptimal experience. So we needed to fix this. What was our initial idea? Well, we decided to go for scale, and we said, more SQL servers and more databases, probably more performant. But think about it, is that really a solution? No, that's not a solution. That doesn't eliminate the problem, it just reduces its frequency. Just because you have more databases doesn't mean there are still some who get hammered and still provide a suboptimal experience, and the resource usage grows exponentially. This is not a real solution. So then we decided to take a step back and think, is there a better way in which we can solve this problem? And fortunately, Azure SQL came to our aid with an out-of-the-box solution, which is awesome, and we encourage all of you to try it. It's called Elastic Pools. Let me explain you briefly what they are. You create a so-called elastic pool in Azure, and you assign a number of DTUs to it. DTUs are database measurement performance units, and their metrics are log writes, input outputs, and CPUs. An easy way to describe them is database horsepower. So one of these elastic pools has a certain number of DTUs assigned to it. And then you create databases. What happens when one of these databases gets hammered, so a lot of connections are made to it? Automatically, a higher number of DTUs will be assigned to it, while the ones which are idle, of course, will have lower number of DTUs, because they aren't doing much. And then when users log in and log out and target another database, with their operations, what happens? Without us doing anything, without you having to do anything, Azure automatically reassigns those DTUs, and thus ensures a consistently fast experience. So both our database clusters and our virtual machine clusters have scaling, have high availability, and have almost no resource wastage to ensure a good experience for our users. Now let's move on to my favorite part. As Kamil said, we're very fortunate to be in Azure because we have some very good and giving neighbors, the Azure services. And because we are a first-party Azure customer, we get a lot of these features before anybody else. So allow me to explain some of the most interesting ones to you. And let's start with the Azure Active Directory. It is the connection point between Office 365 and Dynamics 365. If you recall from the sign-up flow, which I did, when a user logged in, they used their Office 365 account to access Dynamics 365 for financials. And this is stored, as I mentioned, in AAD, as is information about their licenses and other things. So our product queries AAD and asks, hey, I just received the login from this user. Do they have a valid NAV license? And if the answer is yes, without the user needing to do anything, no new account creation needed, we will use just-in-time user creation to give them a user in NAV, and thus the customer can use the product. They have just one account for one Microsoft. I love artificial intelligence, don't you? It's on our phones, it's on our smart devices. Cortana is making life easier for so many people. So why shouldn't it make life easier for NAV customers? Well, now it does, because it's available in the application, so customers who log in can already use it. And it has so many interesting features. For example, it can offer accurate predictions of future sales, and thus help customers avoid inventory shortage. And it uses machine learning to become even smarter as the customer uses it, and give them more advice more tailored to their personal content. Another awesome thing is that customers don't have to worry about downtimes, because we have advanced internal telemetry, which we use for easy troubleshooting. We offer 3 paths, the hot path, the warm path, and the cold path, through which information and events can reach our monitoring teams. And for example, should a critical event occur, The hot path will take over, and in just a few seconds, one of our teams will be notified and will take immediate action to solve it. As you all know, security is our #1 priority at Microsoft. There is nothing more important to us than our customer data, so we made sure that our service was secure. We do not store any credentials, servers, virtual machines, or databases, anyone in our clusters. Instead, we use something called the Azure Key Vault, which is a nifty tool which is easy to use, secure, offers only authorized access, and has some great features such as automatic credential rotation for an even better level of security. And again, these are just some of the Azure services we utilize. I can talk about them all day long, but I won't. We have something else very interesting to show you.
Thank you very much. So, well, we were building the service, and I think we showed you the general picture of what kind of components it consists of. So imagine you build such a system, and you expect a really high load on it. Of course, the moment you design it, and you have some test environment ready, a general architecture everyone agrees upon, you want to check how well it performs. Because, of course, as Constantin mentioned, we can just throw more and more resources, but that is really not a solution for the problem. And also, we want to, at the same time, improve the performance of NAV so each of you can benefit with all the changes we make. So we took a really close look at the platform, and we thought, OK, let's build that entire test infrastructure in order to automatically schedule some huge amount of tenants load tests. So we can repetitively make some changes in the platform, tune the features it consists of, and check how it affects the entire platform performance. So we did build such infrastructure. We created it with thousands of tenants, and we could request any configuration we are pleased with in a particular test run. And we used it to test the performance. And well, here is actually one t-shirt, guys, and one of you can get it if you gonna guess what kind of online service that Microsoft owns we used in order to create such a service. So, of course, we needed someone to use the system, and of course we could go to all the floors within our building and ask all our colleagues to stop working for half an hour and use the system, but that wasn't really a good idea, so instead we used some system. So anyone wanna guess what kind of online service of Microsoft was it? Excuse me? Let's accept that answer. It's a Visual Studio Online service, so I think it was someone out there who answered that. Yeah. Thanks a lot.
He's here.
So, yeah, we couldn't use our colleagues, and instead we used the Visual Studio Online service. And actually, we found it extremely useful. So what we really wanted, we wanted to simulate a huge number of users accessing our huge system, and we wanted to really simulate the real usage of the system. Oh, I really got tired. I think I should run more. So what we did, we actually created tests that would simulate the user operations while using the NAV. Things like sales doc lookup or item lookup, some really simple operations, and slightly longer operations, some scenarios like creating and posting the sales invoice. So we created those tests, and well, you might ask, why didn't you run it from why didn't you run it from your own infrastructure? Well, it wouldn't really be an exact simulation of the real case, because all of those requests would pretty much come from the same subnet, maybe even the same IP address. So it wouldn't really simulate the real network traffic coming from users distributed all around the world. So that's why we wanted to use the VSO. So, of course, we also shared the information. So go ahead and visit that address on the partner source. You will find some videos which explain how you can perform similar tests with your system. I believe there is also some source code available. So go ahead, try it out. So we created those tests, and we ran it against the system. Well, we already had an environment, but really, how can you push the system to the limits? You should really simulate the worst possible case. So what we did, actually, we simulated something that really doesn't happen in prod, which is all the users were accessing the system extensively at the same time, Because usually, as Constantin mentioned, in prod, they would be accessing system at a different time due to different time zone. Maybe there are some local regulations that require some operations to be done, let's say, at the end of the month or before, earlier, at the beginning of the month. So depending on your location, that load is kind of distributed more equally among the time. We actually wanted the worst possible situation simulated. So we basically loaded the system with all the users accessing all the tenants at the same time. So that was one criteria to kind of put the system to its limits. And the second condition was we also lowered the performance tier available to the service. So we use much lower performance available on the database level than we would use in prod. So we kind of gave it less horsepower to put it even more to its limits. So how the results look like. And keep in mind that the results we show right now and also the platform improvements, all of them we could really start seeing at the really high load in a really big environment in terms of number of systems in thousands, or there were even bigger numbers. And probably most of you haven't noticed, or all of you haven't noticed it while running the service on-prem or in cloud with not too big amount of tenants. But coming back to the results, so what you can see right now, it's a graph that presents such simulated usage of the system. So on the x-axis, you see the time that passed as the test executed, and in each single line, horizontal line, represents a single user running against the system. And each color within the line represents a single particular test executed by that user. So what you can see on the first graph, this is one of the first results visualized, so it gives you a perspective of how it looked in the beginning. So you can see there is some warm-up time. We don't really hammer server with a lot of users accessing the system. You can actually see though that they're starting to log in and perform some first operations, and then at some point more users access the service. And as they started executing operations concurrently, the operations took a lot of time to execute. So what we did, we executed such multiple hours load test with a lot of users and a lot of tenants. And then we took a closer look at our environment. So we basically were finding weak spots, and we worked with all the internal NAV platform teams and also app teams, because there were also improvements in app we made based on those results, in order to fix all those weak points and rerun the tests. So ideally, we should see the situation improving, and we did. So that is the first result. And then there is the second result that we got after improving platform slightly, and how we did it, we'll explain it to you on next slides. So this is one of the next results we got, and you can see that it gets better. So some operations take longer than expected in the beginning. So when the user logged in and started executing first operations, it took longer, definitely longer than expected. But then the situation after the NST warm-up, after the user logged in and executed few operations, the situation stabilizes. And you can see that all operations execute extremely fast when compared to the previous state. So again, we took a look at the platform, and then we saw some things to improve, which again really surface only at the large scale while running in cloud. And what kind of tools we used for that? Of course, except of some internal tooling, we also use something that is available to all of you. So if you have databases hosted on Azure SQL, you can go ahead and check the tooling that the Azure SQL team made available for you. For instance, you can check what kind of SQL statements takes the most of the CPU performance, DTU performance, total DTU performance on a database. Another tool can actually recommend you what kind of indexes you are missing in the database. So all those small tools can be used to analyze what is wrong in your data model, what is wrong in a data stack. And of course, there were other tools that we used when we noticed platform issues on the VMs, not in the databases. So what did we finish with? Well, we finished with this result. So with more things improved in the platform as we went further with those test runs, we actually resulted in a situation like this, in which we not only see that the user operations execute extremely fast, there are no delays on any user, and what is more, if you look closely, you can see that actually all the users start executing on the system at the same time immediately. So there's no warm-up time. So of course, first you execute it with some warm-up. We saw, okay, it's perfect, but now let's put the barrier even higher. Let's try to access the NST even faster with all those users. But this is the result we got. So we really spent a lot of time trying to improve the platform. And because this is NAV platform, all of you will benefit from it, regardless whether it's on-prem or in cloud. So let's go through some of the changes we made in the platform. I'll start with explaining some improvements we made that are related to Azure SQL and also SQL Server connectivity. So what you can see on that diagram, a little background, so it's maybe better to understand why was it important. What you can see here are two clusters. One contains of the VMs of our service and also other services. And on the lower part of the picture, you see the databases. There is an app database outside the Elastic Pool and some tenant databases within the Elastic Pool. But you need to remember that there are some hardware resources that those databases are hosted on. So there are also, within the same infrastructure, some other Elastic pools hosted within the same hardware with other databases. And the same for the VMs, there are other VMs present. What does it mean? In terms of the databases, if we draw right now the boundaries around our service, so we will kind of visualize that this is our logical Dynamics 365 for financials cluster. We'll have two VMs, we'll have multiple tenant databases, we'll have app database. And because the same hardware is used by not only our cluster, also by other databases, what Azure SQL will do in the background, it will try to ensure that the performance is always perfect for you. So it will perform some maintenance jobs, like it will try to move some of the databases to the higher performing stack. So basically you see no degradation on the service quality, even though there are more and more databases added on a hardware level. And so because of that situation, you will be informed by the Azure SQL due to so-called the transient errors that situation like this happen, and your platform should respond accordingly. And in the previous releases, of course, we introduced support for Azure SQL, so we did handle those kind of communication with Azure SQL that actually is done to help you, but you actually need to respond appropriately. But we took it even further, so you can see that there are some connections opened here, and there are connections open also by other services. So to handle this in a great way, we actually reinforced even more our retry logic, because as you can imagine now, as the scale is much higher, there are like thousands of tenants. Also, the number of connections is much bigger, which means that we need to be really intelligent in number of connections we open. We also need to handle the drops in a better way and all those throttling issues in a better way. Otherwise, imagine you have a really simple retry logic, and when you get disconnected, you immediately try to reconnect. And now imagine it happens on thousands of tenants. Basically, the situation gets even worse. You get continuously blocked. So we took a really close look at this, and we ensured at the super high, large scale, it performs just perfectly. What is more, also the application DB connections. We look at how we open it, how fast we close it, how much we reuse existing connections, and we also improve that logic. So we don't open the connections too late. For instance, there were some situations in which the connection would be kept alive but wouldn't be used, which means that when you look at the limit on the Azure SQL server level, actually we were taking some spots we didn't use. So we optimized that and to get better performance. And also because we have the hardware resources beneath our logical servers, we had to conform to the limit in number of connections. And again, large scale, you need to be more careful with this, so we improved it more. And Task Scheduler, those of you who've seen the release notes for NAV 2017, you probably know that there's something called Task Scheduler that got executed. And this is one of the results of the work on the Dynamics 365 for financial service that basically ended up with this completely new feature added to the platform. So let me explain you the story behind this feature. What you can see on that graph is the memory usage. You can see there are two scale units we call the VM scale unit internally. So you can see there are two that are load balancing traffic coming to the system, traffic coming from the users of the system. And in the beginning, you can see that the memory usage is around 2.5 gigabytes on each VM, but then it grows. And actually, it was growing as we were mounting more and more tenants. So obviously, that was probably beginning of our performance test effort. So you can see the more tenants are added, the system usage increases, and the same actually happens on a CPU level. So we took a look at that and we thought, okay, we are not using the system extensively yet, but even though we see that number increasing with time. So what was the problem? Actually, the problem was that the NST was constantly pulling for the job queue entries, which was consuming the memory and also the CPU. And so when the NAS was running, for each tenant, company, and queue, there was a separate thread spun up. So you can imagine not only the CPU usage increase, but also the memory usage increase because each thread has a cost on a memory. So what did we do? We thought of not only just fixing it temporarily by increasing, let's say, the VM size. We actually tried to redesign the entire job queue execution. So we introduced the task scheduler. So the task scheduler got introduced again in the platform, so all of you can start using it. And the benefit of using the task scheduler is that there is a single thread that is looking into the application database. It looks for all the job queue entries. And simply, the lower memory usage, the thumbprint, and also the CPU usage is extremely low. So when the NAV server is idle, there's a single thread used to execute those operations. But when you, for instance, want to just a small comment about this, if, for instance, some task is set to run as another yet user, of course, there will be another thread created for that task while it executes. However, it's still much better situation than there was before. So after we introduced the task scheduler, we made the application improvement. And we made the job queues to be optimized by usage of the task scheduler. And thanks to this, we got much lower on the resource usage. And task scheduler is available in platform, so go ahead and start using it today. But there is more.
Great. Thank you very much, Kamil. So as my colleague said, we ran an extensive suite of tests. And he showed you how we analyzed CPU and memory usage. But there is another very important resource we looked at. DTUs. If you remember, DTUs were the database performance measurement unit, the thing which tells us basically how performant our databases are. So let's find out how they behaved when our test was running. Interesting. So what do we have on this graph? On the x-axis, we have the time during which the tests run. And on the y-axis, we have the percentage of resources which were consumed. If you remember, a DTU had three major metrics. One of them is the log write, the other one is the data input-output, and the third one is the CPU. So these three metrics make up a DTU. And what can we witness from this graph? Well, the log writes are pretty good. They're constantly under 5%. And even the data input-output is quite well. It's the one in red here. And it's still, on average, under 10%, so we're satisfied with that. But the CPU usage, slightly different, isn't it? The blue things on the graph just don't add up. So we looked at this and we thought, okay, why are we consuming so much CPUs? Who is the main culprit? Anyone care to take a guess? You'll find out either way, don't worry.
But there is a t-shirt for the person who...
Please, louder. There was indeed something in SQL, but what precisely in our code, like in our application? Yeah, let's accept that. Thank you very much. So we'll give it to this gentleman, because he was first to say. But it was one particular, let's call him individual in our code. The session events table. That was the main culprit. Of course, for operations, but it was consuming many DTUs. And as Kamil said, we got a lot of feedback from the Azure SQL portal itself. And it said, by the way, you are missing indexes in key places. And as you said, we have some other SQL statements which are a bit suboptimal and consuming resources. And then we looked at our code ourselves, and we noticed that in other places, we had indexes which were too many, and some of them suboptimal. So we made improvements. First of all, we looked on the platform side, and we refactored how the session event table works. The loop logic is a lot better, and its DTU footprint has been reduced considerably. So we won't see this anymore. And we took it even further. We took and made application improvements. And we have also added those missing indexes which were suggested, and the extra ones, they're gone. And we have also improved database querying. So now, for example, when we filter on things, we try to do it on index fields, which is a lot faster. And in some cases, we all had multiple SQL statements, which are now replaced by one. It's a lot more optimal. And we even had, let's say, inefficient casting, which has been removed, and thus the time has been significantly reduced. So not only do we have reduced CPU and memory usage, but also reduced DTU usage. Our old friend DNST, I would say it behaves quite well once it is warmed up. But on a cold start, it can use some improvements, right? So as we saw from the test, there was a stage when we noticed that during the cold start, something was taking time. So we dug into our code and thought, okay, what is it doing? Why, is it taking this time? And it turns out the main culprit was that it was needlessly recompiling assemblies. An object was modified, assembly compilation. So we thought, okay, this is taking a bit too long than we'd like. We like our things to be fast. So how did we solve this problem? We looked at our metadata caching, and we have optimized it. And even more, now it is not just for the NAV server, it's also for the extensions we mentioned. So when they enable them, it will also stay fast. And to make things even better, it is actually cached even before the user logs in, so that even their first experience will be fast. But because we're in the cloud, we have virtual machine clusters, right? So there's more than one virtual machines. And even when you may use it on-prem, if you target Azure, you may have more than one machine. So let's say, for example, you go and recompile one of your objects, like a code unit or a page. The server should then have to, recompile that cache, recompile those assemblies, but it'll do it on one of those virtual machines. What about the others? When the customer logs in, you don't know what machine they'll hit. What if they hit one where the cache isn't yet synced? Well, we thought about this issue, and we introduced NHT caching between these virtual machines, so that wherever that item is recompiled, in a very, very short time, all virtual machines will have the metadata cache sync, and the user experience will be constantly fast. And there was one more very interesting thing we noticed. So keep in mind that we ran this test with thousands of users, and we had hundreds of tenants per NAV server. And when one of these servers was started, all of those tenants would be mounted in parallel. And you can imagine what would happen to the SQL Server. You're opening hundreds of connections at the same time in a very short amount. It gets throttled. That is a bad experience. So we fixed it by making the way in which tenants are mounted more controlled, more queued, and the problem was gone. So you kind of saw how things were before, and we kind of presented the improvements. Let's see what they actually helped us with. We have chosen blue, a cold color, to represent the old cold startup. So let's take a look at this graph. We have the x-axis, where we have the multiple tests that we run, different circumstances. And on the y-axis, we have the number of seconds it took the server to start. Keep in mind, this is a cold start, a very heavily loaded system. So on average, we see that it's between, I would say, 2.5 minutes to 3.5 minutes. With these improvements in place, how much faster do you think it is? By a factor of what? Care to take a guess? 10. Go lower. Go lower. A bit. A bit higher. A bit higher. 6. That was it.
Who said 6?
The legend.
Here it is.
It was
You're
a
welcome.
very good guess. So, without these improvements, we took, on average, again, a lot more resources than you would have in a normal production scenario on your systems. Thousands of users, hundreds of tenants. 3 minutes was the average startup time, which is 180 seconds. With these improvements, it went down to 30 seconds, and it will only get better when you try it. And we have one more great improvement, because we think that the first experience is very important. And a lot of our customers, which will become your customers, will try NAV for the first time with Dynamics 365 for financials. So some of you have probably worked with multiple virtual machines and have mounted a tenant on one of them. When you work on-prem, it will be mounted on one of the virtual machines, and it will roughly take 30 seconds for it to propagate across all of them. And in our world so far, this has been good. 30 seconds, acceptable. But not anymore, because we aim for 5 seconds to sign up. Every single second counts. And that can be the difference between a customer seeing this and a customer seeing this on their first try. Bad experience, we don't want that. So how did we fix this issue? Well, we introduced something called just-in-time tenant discovery. And let me give you a diagram of how this works. You're a customer, you access the URL. And of course, you'll hit a load balancer, which will randomly select a virtual machine. Let's say it has selected one where the tenant hasn't yet been mounted. Before, you would get that message, and you would be probably unhappy. But now, the virtual machine will talk to the other virtual machines and say, by the way, do you have this tenant? It will synchronize just in time, and then it will give the user an adequate first experience. So, a quick recap of all the features we have shown you today. We have Azure SQL connectivity improvements by reusing connections and having automated retry logic. We have a new task scheduler for job queues, which made things a lot faster. And we strongly encourage you to refactor your code, especially if you have code units which use the NAS to now use the task scheduler. You won't believe how much faster it is. We have optimized resource consumption, not just memory and CPU, but also DTU. We have a faster NST warm-up, 6 times as fast, and again, those times were on a heavily loaded system. We have reduced COGS for running on Azure SQL. Whether you use elastic pools, which we strongly encourage you to use, you won't believe how awesome they are, or if you don't want to, you can use them on-prem with whatever Azure resources you like, and they'll still be better. And we have the just-in-time tenant discovery for a good first experience every time. And all of these features are in the cloud, running on Dynamics 365 for financials, for all our customers, but they're also on-prem in NAV 2017, ready for you to try out. We cannot wait to get your feedback on these features. So we have shown you how through Dynamics 365 for financials, we shall get NAV in just a few seconds into the hands of every small and medium business on the planet, and how we have improved our on-prem product by creating it. That's quite a lot for a session. However, there is one more thing.
Thank you very much, Constantin. So yes, there is one more thing. We'll switch more to a runtime experience now on us monitoring the service. And in terms of the platform improvements, we really did more. But those examples you've seen were from slightly different areas. So we showed at least one change that actually ended up being a completely new feature. We showed you something that decreased the warm-up time. We showed you also something that decreased the memory usage, so affected positively the VMs, and also something that affected the servers. As Constantin said, let's switch to something else, otherwise there will be no more time. So let's look at the monitoring, telemetry, and insights. And we mentioned in the beginning that the monitoring and telemetry was extremely important to us, because really when you have this large-scale service like Dynamics 365 for financials, you must know what's happening with the system, right? You cannot just know whether it's up and running or not. You need to know how the system is used. So we spent a lot of time. There was a specific team even responsible for this, so it was extremely important. It was not just a feature. It was the effort that we continued along the entire project. And whatever other teams were creating, they must have ensured that there's appropriate telemetry information added, so the entire picture looks complete when we start running the service. So let's take a look at the monitoring and telemetry and the insights that you want to have on the system. So when you build a system that allows you to get such information, you think of 3 things. You first look at something you emit. So, of course, you need the information first. So you emit the information from each and single component of the system. Then, of course, you need to scrub the PII information, the private data, like the unique user ID or the IP address or whatever can uniquely identify the user to comply with all the regulations. Then, of course, it's a huge amount of raw data. Raw data is great because you can process it further and you can find some new usage for the data, so it's pretty clever to keep the raw data. However, you also need to transform it. If you want to, for instance, use the Power BI, it won't probably consume petabytes. You probably will use smaller amount of data if you want to, for instance, to get some graphs on a dashboard. And of course, you consume the data. So we basically divided our work into looking into those 3 separate steps of building such a service. So let's start with with a short explanation on what kind of information we emit in our system. So we start with the health runner, which is responsible for outside-in monitoring. So it's a good idea to look at the system from the outside. So that's why we created health runners that were trying to contact each of the tenants that we had running in prod. And they were not only checking if the tenant is there, it was actually checking if it's responding correctly. So it was ensuring that whatever call it makes, it goes through entire NAV stack, so through the web client, the NST, the database, and performs some real work. So it actually guarantees that the tenant is fine. But there is more. Of course, we have management portals, and management portals have information about how many tenants we deploy, where the tenants are located, on which Azure resources. So basically the management portal, except of course a normal health information it needs to provide, it also provides some inventory information. But the management portal also is participating in executing some management tasks. So whenever we provision a new tenant or we do some upgrade in order to switch to a new platform, Beats or the app version, it also provides the information about what kind of operations it executed, so we know if there is a problem upfront. And of course, there are VMs. So probably most of you read the MSDN documentation, and you know that we generate ETW and application events, and probably most of you also used it in prem. So we also look at the ETW events, and we extended the set of the events, and we created something, we installed something called the monitoring agent on each of the VM. And why did we do it? Because we didn't want to store that information locally on the VM, because let's say the VM goes down, you lose the information. So we deploy so-called monitoring agents that is responsible for transferring data further, and it gives us a better insight into the state of the VM. So we know what's happening both on NST and on the web client. But when you look at all those components, there is something common for all of them. And that is actually that they're all on the server side. And you cannot really get really good information in terms of telemetry. You don't really get a really good insight into what's happening in the system if you won't also do it on the client side. So that actually doesn't complete the picture yet. We also have the client components. So as you can see, there's also a browser, because you will probably access the Dynamics 365 for financial service through your Office 365 account. There's also, of course, device app. As you know, thanks to the usage of the Dynamics NAV at the heart of the service, there's mobile device support for all operating systems. So some of you will use the device to do it. And then, of course, there's a landing page. The landing page is the component that Constantin presented, I think, on the second slide, which participates in the sign-up experience. So when you provide your company details, then you wait those 5 seconds, and during those 5 seconds, you see the landing page. And you might ask, yes, but what's so special about this? Well, it is really important for us, because thanks to that telemetry we get from the landing page, we actually know how long you really waited for it, whether it was below the 5 seconds our goal is for, or whether it was more, whether you closed the browser, didn't wait for it, all that information we would like to know so we can improve the system. And imagine, hypothetically, the tenant doesn't get created and you're informed about this. Before you contact us, it's gonna be already probably be fixed by now. Because we'll get that information up front, we won't need to wait for you to tell us about this. Appropriate team will get a notification and it will be fixed as the problem arises. So that was actually one of the goals while we work on the monitoring and telemetry, the fact to be able to react proactively. Not to wait for the customer to tell us there is a problem, but to fix the problems before there is a problem. And for the devices, of course, we also need to know what kind of operations are performed. So actually we'll cover it in a demo pretty nicely, so I won't tell you more about this for now. Let's concentrate on Azure Application Insights for a second. It's a component that also resides in the emit part of the system. We actually placed it there because we wanted to emphasize that this is the component that is residing and is accessible from outside Microsoft infrastructure. Because as you can imagine, you're accessing the sites from outside our CorpNet, which means that in order to collect this information, we need to have a service exposed. And Azure team, again, came with help for that problem. They created the Azure Application Insights, which allows you to collect the telemetry from your applications. And we use that system with a great success. What is critical when you create such monitoring and telemetry system is to ensure that you don't collect too much. So we would like to know how the system is used. However, we must, comply with all the regulations. We don't want to store the private information like, let's say, AAD username and email address. We don't want to uniquely identify that it was you, or you that executed at particular time this particular operation. So we want to know how the system was used, but with conformance with all the regulations. So before we do anything with the data, we ensure that it's scrubbed from the private information. So both the tenant uptime time and the inventory and operation telemetry, all the ETW events and operations registered while on the client side, all of them get the private information removed before we have access to it. And Constantin mentioned already that we distinguish between so-called paths. So when you think of a monitoring system, you will probably start by, of course, looking at how to divide that data you get, because you get a huge amount of information. And how we actually divide that information is we call them paths. So there are 3 paths we distinguish. There's a cold path, warm path, and a hot path. And how do they differ? Well, they differ in many ways. There's a different way we store different type of information. For instance, if something we use more for BI purposes, more like for showing in the Power BI dashboards, that information should be probably really historical in terms of like how many days back we collected that information. It doesn't need to be really quickly accessible, like within a matter of seconds. There can be some job that process this data. It's not so critical. However, in an example that I think Constantin also mentioned is that in a situation when something goes wrong, like the health monitor informs us that the tenant is down, or we see, thanks to some other subsystems, that there's a problem with the system, with the service, we would like to know about this within seconds. And that's why there's something like a hot path. So how do they differ? So for the hot path, we use a big data storage that is extremely fast in terms of the access. So we can query, we can create the alerting, we can create everything, and we know that even though amount of data is big, it's extremely quickly processed. So there is no delay between some occurrence of a critical event and the time internal team gets notified. For the warm path, well, imagine there is a problem and we can see that there's a kind of, let's say, exception thrown on the server side. We'll troubleshoot the problem and we'll show you a real demo of that in a second. But for this type of information, you won't need to probably get the details about how, let's say, how often it occurred within, let's say, a second. It can take 10 seconds, it can take 1 minute when you make a query and you get all the historical data about how often it happened. And that's why there's something like a warm path. It's something that we don't need to get extremely fast, so we use a slightly different data storage for that. And as I said, there's a cold path, which is used more for further processing, to be used for, let's say, Power BI dashboards or to get some other statistics. So that's why we distinguish between those 3 paths. One is important in terms of alerting and real-time monitoring. The other one we use to get a more insight into how the system is used. So there are different purposes, different data storages, and different consumers for each type of the information. So how the hot path is consumed? Well, those are all internal systems, so we won't tell you a lot about this, but just to sum up, we have some monitoring and alerting system that is reading the information from the hot path, and based on the information it receives, example, tenant is down, it immediately ensures that appropriate team members is notified about the problem. Again, all those issues we get notified about before even you notice the problem. So that's the hot path. For the warm path, it's mostly used for the troubleshooting, for checking the logs, for seeing how the system was executed in order to maybe think of what next features we should provide, and also the cold path will be used for that. So we want to see what part of the product was used in order to know what part of it we should improve. because it's used the most often, for instance. And also for some daily statistics that we use the Power BI dashboards for, or some other information. Basically, the cold path contains the most of the data in terms of the amount, and it looks back with the highest time window. And in that case, because it's a lot of data, but it's not really critical in terms of how fast we process it. So we can create some jobs that will process, let's say, petabytes of data, maybe not extremely fast, but it will give us a better insight on the system. We mentioned Power BI, and this is one of the dashboards you can see right now. So this is a type of information, and this is just a sample, what kind of data we can get. This one, for instance, gives you an insight of how many users use the system, when was it, like how many signs up we had, how many people visited the site. So this is a sample data we feed it to this graph. And we can take a look at this daily. It is not super critical, that's why it's not coming from the hot path, but it's extremely nice because we can know who's using the system, how many signs up there are, how often user access the system. It gives us great capabilities, and we can really create a lot of those and get a better insight into what's happening in the system. So we collect a lot of information, but probably you would like to maybe get a good example of how we use the warm path. So let's get there.
Okay. Thank you very much, Kamil. So for the finale, we shall demo how we troubleshoot an issue. And these are the exact steps we would take if this issue would occur in production. So let's imagine that somewhere out there, there's a customer, and they have logged into Dynamics 365 for financials, have played around, but when they try to post the first sale invoice, they get an issue. So what does the customer do? They contact us via email. Here's the email they send us. They say, "Dear support, when I'm trying to post my first sale invoice, I'm getting the following error." And we get this error, we see this number 1896, and we see it was on the sales page. The customer is, of course, tenant in trouble. Coincidence? I think not. So what is our next step? We create a ticket, and then we have to analyze and see what caused the issue. In order to do that, we have to determine a few things. First of all, where did it occur? For which user? In this case, we know it is for the user called tenant in trouble, and we know which cluster they are deployed on. Once we have that, we have to determine what kind of issue it was. And you know, many errors can have different underlying causes. But we know at some point in this flow, a CAL error occurred. We see it right here. So we know what kind of error to look for. And once we have that, we of course have to identify the time frame, the when during which this occurred. So let's say for the purposes of this demonstration that it occurred yesterday and let's say more than 1 hour ago. So once we have all that, we can connect to the relevant cluster and create a query to retrieve the telemetry data. This telemetry data will help us analyze the issue. And here is a sneak peek of the tool we use to explore the ocean of data. Before this demo, we created a function called AL errors, and you're never going to guess what it does. It retrieves AL errors. And it has 4 parameters. Sale, because we know it occurred on a sales page. Tenant in trouble, which is the name of the company. And the third and fourth parameters are the time frame. So as I said, for purposes of this demonstration, let's say it occurred between a day ago and an hour ago. So after that, in our nifty tool, we run this function and retrieve the relevant data. And as you can see, this is the data we have retrieved. And by going through it, let's look at the highlighted one. I'm not sure the font is readable. It says tenant in trouble, because that is the company. And then let's look at the description. Blocked must be equal to number item 1896S. That looks like our culprit. And I'm just going to direct your attention to the session number 12, because we're going to come back to that a little bit later. But now think if you were that customer. Actually, think more general. Let's say your computer had broken down, and you call support. What is the first thing they usually ask you? What were you doing when the issue happened, right? They try to ask, what are the repro steps? But why should the customer do that? The customer shouldn't have to explain to us what they were doing. Our telemetry should let us know. In fact, as Kamil said, the customer shouldn't even have to write the email. Why do they have to contact us for an issue on our side? We should be able to fix this using our telemetry. And we can. Because all we need to do is, as I mentioned, look at the incident and remember that session ID 12. Based on that, we can retrieve something called a unique server session ID. And this is a GUID, which is the same for all operation a user executes during a login session. So if I log in, do some operations, then log out, all of the operation I did will have the same server session ID in our database. And here's how we can retrieve them in our tool. Once we have the error, we write this code which retrieves the unique server session ID for session number 12. And let's say it retrieved this GUID. We then retrieve all the operations for this GUID. Again, Kamil just showed you. This is all trimmed out. There's no user data here, no personal information. These are just events triggered when the user has clicked on different items, which help us proactively troubleshoot issues. So once we have that and we have analyzed the action, let's actually try to reproduce the bug. So on the left side of the screen, you shall see our reproduction environment. And on the right side, I shall keep this list so we can look through it and not have to switch context every now and then. So here we are now reproduction environment, which is the financials application the customer was using. And we also have these operations, right? So what did he do? He logged into Office 365, it was getting started, and then they closed that welcome experience. This is what this operation does. We did the same thing over here, as you can see. And then we usually would go through this list, right? We have the item list, the item card, and different operations. But neither of those caused the problems. If we were to go through them one by one, they would all be fine. Until we got to this part. So at some point, they opened the sales invoicing list, and they clicked on post sales invoice. And we do the same. And then we try to post a sales invoice ourselves. And here is what we get. Do you see that error message? Block must be equal to number in item 1896S is the exact same error message they got. So now, just by using our telemetry, we can actually have the reproduction of the bug, and even more. Because if we go back, if we double-click on one of the queries and look at this error message, it's blurred out here for obvious reasons, but we get the stack trace. So not only do we know how to debug, we know where to debug. And again, this is done proactively without the user having to contact us. We can analyze these issues on a daily basis and improve our product in the cloud. Kamil?
Yeah, I think it's pretty powerful. I don't know what you think about this, but you can just think of scenarios like looking for the most occurring exceptions or most occurring AL errors. I mean, possibilities are endless, really, when you have the right information at hand. So guys, I think we really gave you a nice description of how the system is built and how we operate it, but we are also sure that you might have some additional questions. So we have still a few minutes right now, and of course, after the presentation, feel free to ask.
Yeah. So like Kamil said, don't worry if we run out of time here. We are here at the walk-in dinner. I'm here tomorrow. Just grab me whenever you can.
Do you mind throwing at people?
Okay, so I'll throw here because I think this gentleman raised hand up first. Excellent.
This tool, is it going to be published? Is it going to be made available for on-prem customers in any way?
So the ETW events are already generated on, for instance, NST. So when you go to MSDN, you can already set up the system. So for instance, let's say SQL operation will generate appropriate ETW event, and then you can use the tooling for processing this to get necessary information. So you need to think more about how you process the data further, but already you will get similar information from the platform.
That would include sort of NAV-related operations? Because
yes. So when you go to ETW, there are several types of information. For instance, you can be notified whenever a certificate used by the NST is about to expire, or some AL-related events, or for instance, all the SQL-related events. When the statement gets executed, it can inform you as a ETW event. However, be careful, because if you enable too much, it will also affect the performance, because it will basically inform the telemetry system about each operation. But it's really detailed, and I believe on MSDN there is a list of all the event IDs and what they represent.
Okay. I think it was over there, so if you can just pass it in this area, and then we'll move it around.
Thank you for the example where you showed the item error, the item blocked error.
Yes.
How do you differ between those errors and real errors in the reality? Because I think the typical customer will get 100 errors a day and they're all no problem in it real. How do you differ?
I don't think they would actually get 100 errors per day. So basically, you can imagine we have the telemetry in place and we can determine what types of error occurred. And there can be different causes for them. but we can always analyze them and see what the actual cause was, right? For example, we can look at frequency and say, these are the most frequent ones, and they're occurring quite a lot. Let's see if they're, like a read error, an access error, or there's something we can improve. And we always try to get them as low as possible.
And besides, just to add something to it, so because we have the historical data, we look at a particular error once. So if it's really typical error, we'll see it really quickly, and then we can already filter out in the dashboards or in the alerting systems that particular, error, should be ignored. So maybe we'll spend a few seconds of our time, but then later on we already know the problem is not something we are interested
I'm
in.
looking forward for the next 2 to 3 years when you're going to track all those errors and fix them in the application, then NAV will be really perfect.
We're also looking forward.
Yeah.
Okay, the gentleman behind you.
Okay.
Thanks. You talked about the just-in-time tenant discovery. Do you do this globally? Meaning, do you do global geographic load balancing? And for example, how do you fix the problems or solve the problems with the database charting and database replication? Meaning, customers accessing the same tenant all over the globe.
So if you ever use the management portal, we know that we have something called application services. And those things are Azure services, actually. And we group tenants in those application services. They have a bunch of virtual machines which help them run, the ones I showed you in the cluster. And they're also grouped geographically. So we try to avoid, putting data in the same place, North Europe with the United States, for example. So we separate them. And when one of those virtual machines will ask the other ones, it will only ask the ones in the same cluster. So for example, if you're in Australia and then you try to get a tenant, you won't ask the ones in India, for example, or the ones in Europe. You'll just ask the ones in the same application service cluster.
Okay. So you will still have latency issues if you're trying to access a tenant that was set up in India, for example, but you're in Australia at the moment.
We have made logic that waits. So the user will log in and they'll get a loading screen. Until the tenants are actually synced, they will still see the loading screen, and then they'll get either an adequate experience, or if the tenant they're accessing is actually invalid, for example, the URL is wrong, then they will get a message. But as long as the tenant exists, it will appear. Okay, where do we go now? Anyone else? There I see someone. Oh, can you throw it all? Just
I think we need to encourage people with more T-shirts. So Constantin.
Okay.
Thanks.
There you go, sir.
Are you having any plans to backport NST improvements to 2016, for instance?
That's a really good question. So maybe let's take it offline. I think most of the changes we do, unless there are some, they have some dependencies in something that is only available in 2017. We need to make sure that there are no issues when you switch to a newer build, that you don't need to rewrite the app. So, but usually whenever we can, we do improve the previous builds with what we introduce. So we would need to go with the list one by one and see what already got ported or what is planned to be ported. We look at the cumulative updates basically, and we decide on a weekly basis what gets there. Yeah. So if you're interested in this, you're more than welcome to contact us and ask about the specific improvement, and we'll confirm or whether it is gonna be there or not.
Any other questions? That seems to be it.
Okay. So thank you very much. We really hope you will all try the Dynamics 365 for financial service, and again, it will be available for some further questions if they arise.
Yes.
Thank you very much.
Very much.
Thanks.
Thanks.